If we are performing actual constructions, a project engineer must possess the skill of being knowledgeable in interpreting the civil drawing into reality. For example, your current activity for your crew is fabrication and laying of RSB for footing. Therefore, you will base it from the provided schedule or cutting list of a combined footing. Let's say CF2. The footing foundation is 3.2 meters by 6.2 meters with thickness of 0.675 meters. The clear cover is 0.075 meters with top reinforcement of 25 pieces spaced at 0.275 meters along X direction, and another 25 pieces spaced at 0.290 meters along Y or Z direction. Our combined footing is doubly reinforced, and as per schedule, it shows another 25 pieces spaced at 0.175 meters along X and 25 pieces along Y or Z direction for its bottom reinforcement. Now we go to the typical section of combined footing. Observe that we also have an item for structure backfill. Structure backfill, gravel bedding. Then before pouring of slab, we have a regular fill. If you can see, the slab is designed to have a vapor barrier or vapor retarder here. If you have a concrete floor in continuous contact with a source of moisture, you will have problems. This is why vapor barriers or vapor retarder is used under concrete. It is essential. Vapor barriers are a way to keep moisture from getting into the concrete. Next, foundation plan. It is a top view providing project managers with the number of units of columns and footings. It also shows the area of slab, the location of the structural elements like columns, wall footings. We also have the dimensions such as the running lengths of wall footings and grade beams if there is, but there's no grade beam here. So for example, from this plan, we have 8 identical column footing, F4, and vertical stiffeners located along section 5. We also have along section 3 and 4, we have total of 8 identical C1 F1 and 3 C2 F2 along 3 and 4. One, 2, 3, 4, 5, 6, 7, 8, and 3 C2 F2. 1, 2, 3 along 4. Ground floor slabs are designed 0.1 mm thick, reinforced with 10 mm diameter, and spaced at 0.5 meters on center both ways. A floor plan is different from a foundation plan. A floor plan is a top view plan that shows the detail of the room or its corresponding functions, such as the model house, kitchen, living area, resource room, classroom, corridor, bedroom, toilets, laundry, entrance, exits. The location of fixtures such as blackboards, tables, seats and chairs, cabinets, doors, and windows. These are also shown here at floor plan. For example, along section 4, There are identical 4 units of D3 and 2 units of W1 or window 1. Next, for this typical beam detail, we notice that the number of top bars at the left and right support is 8, while the top bar at midspan is 5. The excess 3 from the left and right support is called the discontinued stiffener bar, and the excess 2, which is labeled SFR bars, are called the continued stiffener bars. As shown from this typical section, we have stiffener bars at top and bottom along left and right support. This type of stiffener is called discontinued stiffener bar. Next, another example, let's take B9. The number of continued stiffener bar is 2. B9 stiffener bar, continued stiffener bar is 2, and discontinued stiffener bars at the top, reinforcement along left and right support is 10. That is, the number of continued stiffener bar at the top is taken 5 plus 2 along left and midspan and right support. Therefore, the remaining 3 is added to 5 and 2, which makes it 10 for each support. For the bottom reinforcement, there is no discontinued stiffener bar since the number of required reinforcement along the support and midspan are all identical. So 5 plus 4, that is 9. For additional window details, we have different kinds of opening mechanisms. We have the double hung, sliding, awning, casement, hopper, jalousie, and fixed type. For roofing sheets, we have terracotta, the rib type, corrugated, tall shingles. Notice that the kind of window mechanism used here is called a skylight window. The fairing ceiling system is a suspended steel framing system clad with gypsum boards, or we can also use fiber cement boards. Its grids are concealed behind the ceiling board. The finishing surface would be smooth. The term metal fairing or MF system refers to a non-structural metal attachment that is used to hold a finished material, often used as a technique for creating a seamless plaster internal finish with void behind for the installation of services. Metal fairings are also used as an alternative to traditional timber batten construction for walls and ceilings. Next, we have the project schedule. Project schedule comes in different forms like a timetable or time frame of charts that helps project managers to track their construction progress. First, we have the Gantt diagram or Gantt chart. It is a timeline bar chart. It was named after Henry Gantt, who designed his chart around 1910. Gantt originally created this tool for systematic and routine operations. He designed this visualization tool to easily measure productivity levels of employees and gauge which employees were under or overperforming. It has two main parts, a task list on the left side and a project timeline on the right. Gantt chart is one of the simplest visualizations of project tasks associated with construction project scheduling. Each job or activity is represented by a bar whose length represents the start and end duration of the task. Next, we have the traditional PERT CPM. PERT is a visual project management technique where we plan, schedule, organize, coordinate, and control uncertain activities, while CPM is a statistical technique where we plan, schedule, organize, coordinate, and control well-defined activities. Next, we have PDM. PDM maps out project development by creating visual representation of critical paths and dependencies. The primary output of PDM is a project schedule network diagram. PDM, or precedence diagram method, is of a network of work that is generally visualized like a direction or rectangular shaped clue with its arrows, which indicates an activity of further work. Here we have an example of PERT CPM. From the table, the critical nodes are 1, 2, 2, 5, 5, 7, 5, 8, 7, 10, and 8, 10. From the table, there are two possible critical paths. We have 1 to 2, 2 to 5, 5 to 8, and 8 to 10. And then we have also 1 to 2, 2 to 5, 5 to 7, and 7 to 10. Here's an example of PDM. Let's say for a flood control rehab project, we have 4 activities. Our first activities are rechanneling with percent weight of 1.12%, simultaneous with installation of tarpaulin signboard, which is 0.03%. Yung SS means start to start. The activity can start together with another activity. The FS stands for finish to start. For instance, the structure excavation activity can only commence after rechanneling work. The structure excavation is indicated 28 days duration, with a predecessor increment of 4.5 since the bar chart is scaled 1:0.5 days. The 32 indicates excavation is finished at the 32nd day. This item is early succeeded with 17.5 days by rubble concrete works, which started at 14.5th day and finished at the 68th day. Our obvious critical path by looking at the bar chart and PDM are items SPL1 with code 1, 103 with code 3, and item 507 with code 4. Another scheduling element is called the S-curve. The S-curve is a graph that shows relevant cumulative data for your project. The data can be cost or person hours. The S-shaped curve is also known as the sigmoidal curve or sigmoid curve or the Histic curve. Typically, the S-curve tracks work progress, forecast cash flow, and assesses performance. The S-curve's ability to display real-time cumulative data and compare it with the planned progress is the key reason. Just a few history background. The origin of S-curve or Histic curve goes way back, namely into the studies of population growth by Pierre-François Verhulst in 1838. Verhulst was influenced by Thomas Malthus's an essay on the principle of population, which showed that growth of a biological population is self-limiting by the finite amount of available resources. Anyway, we have an example of project schedule as shown in a form of bar chart or Gantt chart included with S-curve. During planning phase, we project the baseline curve, or some call it the baseline or target. From the example, it is represented by solid purple line, and the red dotted curve is derived during the actual implementation or construction phase. As time progresses, growth begins to accelerate. This growth is represented by the middle section of the S in the graph, which shows rapid rise. And we have also the point of inflection. It is where the growth is at its maximum and begins to accelerate rapidly as additional progress is achieved, creating the upward slope which makes up the center of the S. This means resources like the manpower or equipment work tirelessly at the most significant expenses incurred. The growth slows down after point of inflection, creating the upper asymptote of the S, or the mature stage of the project. It is because the project is winding down and it is mostly finished now, or say it is the finishing touches stage. For most project schedules, one way of checking consistency of your S-curve is determining the value of R square, which must be less than or equal to 1. The closer the R square value is to 1, the better the fit. An R square value of 0 indicates that the regression line does not fit the data at all, while an R square value of 1 indicates a perfect fit. For this example, our S curve's square value, R square value is 0.9903, meaning our data is good fit. It compares the fit of our model to the fit of a horizontal line through the mean of all y values. That is explained by the derived equation as shown. We now interpret. Our data shows us that the activities are heavy during the second quarter, with a periodic percent weight of 42.98%. That is during weeks 2 and 3. However, during the actual implementation, the contractor encountered tirelessly period of work during the third quarter, with a periodic percent weight of 36.89%. That is during the fourth and the fifth week. The periodic data is the total percent weight of accomplished activities bounded within each quarter. The cumulative data is calculated by the incurred periodic percent weight plus the previous accomplishment. Our second observation is the slippage. For the first quarter, the actual progress is ahead of the baseline, meaning it is a positive slippage. For the second, third, and fourth quarter, we encountered a negative slippage. We observed that the actual progress is no longer meeting the required target duration. Slippage is the time when the team is delayed, a task is delayed, or a task is underperformed ahead from its schedule. It could be a negative or positive. For this instance, during the second quarter, the contractor encountered a negative slippage of 1.97%. However, during his first quarter, he had a 4.86% positive slippage. How about what if the contractor encountered this negative slippage? There are certain criteria where a contractor is issued with a department order or a notice letter. If the negative slippage reach 5%, it is called the early warning stage. The contractor is hereby instructed to submit a detailed catch-up program on fortnightly basis to eliminate the slippage. If we say fortnightly, it means 2 weeks. If the negative slippage reach 10%, it is called the ICU stage. It means the contractor is required to submit a more detailed program of activities in a weekly basis. It's no longer 2 weeks or fortnightly basis, but weekly. Site supervisions are intensified and project evaluation is done at least once a week. For negative slippage of 15%, we call it the make or break stage, or sometimes called the terminal stage. The contractor shall be issued a final warning and required to come up with a more detailed program of activities with weekly physical targets together with the required additional input resources. If the contractor failed to submit his reasons and catching up requirements, his contract will be terminated. He is supposed to give reasons, but if he did not submit, then he is suspended or dismissed to take another project, and worst case, his contract will be terminated. The remaining work will be taken over by the administration or to another appropriate contractor or agency. For our example, the following slippage data has not met the criteria to be subjected for issuance of department orders or notices. However, the contractor is under observation of his project evaluation, especially the liquidated damages he incurred in his final quarter. Liquidated damages. This occurs when the contractor has not satisfactorily completed the project on schedule. For instance, the remaining scope of work is 500,000 pesos. The contractor had completed the remaining in 10 calendar days. Therefore, the liquidated damages is computed as 1/10 times 1% of 500,000 times the number of calendar days, which is 10, and that is equal to 5,000 pesos. But we have limits for LD or liquidated damages. The procuring entity may forfeit the contractor's performance bond and take over the project and award it to another appropriate contractor if in case the delay or expiry date exceeds a time duration of 10% of the specified contract time, including the time extensions, or if the total sum of liquidated damages exceeded 10% of the contract price. Okay, so here ends our interpretations. We discussed about some instances in the plan, some materials. We also had discussed interpretations using Gantt chart, PERT CPM, PDM. And lastly, we have the S-curve, interpreting the negative slippages and computing for the liquidated damages.